Well, they did it. They actually did it. SpaceX landed Super Heavy, got it caught on the Mechazilla arms, and safely returned to Earth. We also saw the successful flight of Starship to space and its survival through the atmosphere, soft landing in the ocean. What a day for spaceflight. Once again, I'm joined by my good friends Marcus House and Scott Manley to break down the most recent flight test from Starship. We talk about sort of what SpaceX was planning to do getting into this mission, how the flight performed, just the incredible success of the capture of the Super Heavy booster, and then Starship heading off into orbit and then coming back through the atmosphere. And we sort of talk about each part and then the implications and what the future might hold for this. So enjoy the breakdown analysis of flight number 5 with Scott Manley and Marcus House. Marcus, Scott, we're doing this again for the 5th time. And thank you guys for joining me once again to sort of discuss another incredible test flight mission. And this is surreal. I feel like we could just say, just wait, great, and then we can just wrap up the conversation. But I think we need to sort of explain. Perfect.
Yeah.
But I think we need to explain how and why it went so well.
I mean, you're probably going to bleep this, but my response was once again, holy shit balls, they caught it. I love that there was a post that said, there are not the words to describe this. And somebody said, yes, there are.
Do you remember that Onion
it shouldn't be this easy.
article where man walks on the
walks on moon holding thing.
I guess that's the one. Yeah. Man walks on the fucking moon. Are you getting this, Houston? Yeah. Anyway, all right.
It truly captures the awe of that.
So where do we start? For those of you who are completely uninformed, we saw the 5th test flight from SpaceX of the Starship Super Heavy stack. Marcus, I always ask, what was the plan? What were they hoping to accomplish with this Flight 5?
Well, the immediate objective was that everybody's really focused on was the catch attempt of the booster, which at the time it seemed like an absurd thing that would more than likely not happen because there's all sorts of abort modes that come into play there. And along with that, of course, they wanted to make sure that they could improve the re-entry process for the Starship and land more on target than they did last time. Last time they had the burn through of the flap, which largely almost came off. At least one of them did. And then it landed off target, but, still reasonably successfully. So I wanted to see improvement on that. And obviously a catch of the booster, which, I don't think any of us expected that the result would be what it was.
Yeah, we'll get into that. Right. So catch the booster, don't destroy the booster, fly to space with Starship, re-enter the atmosphere, launch with some degree of accuracy, don't have its fins burn off in the atmosphere. That was the hope.
That's it. And they weren't going for a full orbit. They were remaining suborbital, very close to orbital velocity again, so that they would come down over the Indian Ocean, very similar to the plan last time. So the main difference was this booster catch. So yeah.
So Scott, watching this rocket sort of get prepared and take off, what were you watching as you were seeing the booster start to lift off?
Well, first thing you look at is when a booster starts up is are they counting down through the sequence? You want to make sure that all the necessary landmarks in the countdown are going on. You want to make sure you see that the flame deflector, the shower head, go off, and then as soon as it leaves the pad, you want to count all the engines, make sure that they're all going, and make sure that it looks like it's accelerating good. And then at that point, it's like it's home free. We've seen this before, 4 times before. It had all the engines running. It accelerated beautifully up through the clouds, through max Q, and it launched just at dawn. Literally, there's a shot that shows the sun right on the horizon as it's ascending upwards. So it was actually a very photogenic launch as these things go. It was like the golden hour, as they say. And there was a lot of nice colors on the rocket and the plume as it went upwards. But yeah, what we were looking for was it to have everything working right up until staging. And then once staging happened, we
Yeah.
wanted to check out to make sure that everything else was going on right so that they would proceed towards the catch attempt, because there were multiple points in this where they could call off the catch attempt. In fact, they had to explicitly transmit a command to proceed into the catch attempt scenario or whatever, catch attempt. Yeah. So we were just watching for all those telltales all the way up. And we were somewhat less concerned with Starship. We sort of knew that its time would come later.
Mm-hmm.
So the first 10 minutes were really all about Super Heavy doing its thing once Starship got clear.
And, early on, the hope was that they would, have the staging ring be part of the top of the rocket. Then with later versions, they actually ended up ejecting that staging ring. We saw the same process. We saw the ring falling beside the booster after the staging had happened. So Marcus, talk us through like what happened with that whole staging part of Super Heavy and Starship.
Yeah. I mean, that was sort of around that same time of the boost back burn ending. So they flipped the booster around. They power it back for roughly, I don't know, 53 seconds, 55 seconds, something like that. And then they shut down some of the engines, leaving just the three remaining. And then they finalize that burn to just make sure that everything's nice and precise. But then they let go of that ring. I don't think we actually saw a good shot of that this time. We could sort of see it from a distance view from the ground, actually. And you could sort of see this little speck moving away. So we didn't get a lot of footage of the ring like we did in Flight 4. But yeah, all that went textbook. That stage separation shot, I don't think that's ever going to get old. It's just so spectacular watching the different stages of all these intricate engines, the 33 engines shutting down in sort of sequence, most of them, leaving some going right at the end there. And then just this beautiful separation and this booster falling away. And there was even a great, if you sort of look closely, there was kind of this little glint of the booster firing its boost back burn in the cameras of the second stage, the Starship stage pointing backwards. It was really cool to see. But from that point of view, all the way back to Earth, we were just fingers crossed all that way.
Yeah.
It's just incredible.
Scott, we saw sort of this really nice view of the rocket. And we could see not only the bottom was doing its burn, but there was like these puffs of gas that were coming off of the side, a little up from that. What was going on there?
Well, you've got an object that needs to be able to rotate in multiple axes, so it has reaction control thrusters. And an interesting optimization in Starship is, like on Falcon 9, Falcon 9 has to use these reaction control thrusters on top. And they use compressed nitrogen inside compressed, COPVs, right? Cylinders of high pressure gas. Starship has decided to optimize those away for some procedures and use gas from the tanks. They have to fire these to out the top to make it rotate around when the engines aren't firing. Now, they can use that when the engines are firing, but when the main engines aren't firing, they absolutely need to fire these. And you can actually see in the shot where the ring is falling away, falling down the side, that it's actually firing its thrusters to move slowly past that ring. That's basically very carefully trimming its position so that it can be on target. Yeah, so the reaction control thrusters are needed for this very fine control and targeting of the booster. They're much lower thrust. They give they're very capable at rotating the booster, and they're also needed to help with propellant settling during the descent prior to atmospheric interface. So they just need those for all sorts of things. And these boosters, I think it is kind of beautiful that in the early morning sun, there was all these puffs of gas. Some of them were from the engines as well. After they shut down the engines, there's inevitably some gas that continues to purge through. There's boil off in other regions. So this is a very much a living, breathing object. This building size thing, which is flying through the space at Mach 4 and descending towards the atmosphere. It is very much a living, breathing creature.
Marcus, when it was coming back, it was glowing red. And it wasn't the rockets firing. Like, why? What was going on? Why was it still so hot?
Yeah. I mean, it's just like Scott just said, it comes in to the atmosphere at such high velocity, much higher than Falcon 9. If you compare the numbers, don't have them in front of me right now, but it comes in at many times Mach speed, and it hits that atmosphere, causing all sorts of entry heating on those engines, the entire aft section. So as it comes back, it looks like the whole thing's actually lit up. It's not at all. It's just so hot from that entry heat. It's an incredible shot because we haven't seen that before. That was a first for this mission because we had ground cameras looking right up at it as it came down. So yeah, it's extreme pressure, and as we saw from later shots, it did twist up some of those, at least some of the outer Raptor engine bells, because that's a hell of a lot of force on that.
Yeah, force and heating, let's be clear, right? Because when you heat up metals, they get softer. And this is something, the Starship, the Super Heavy does not do an entry burn to slow down, right? The Falcon 9 has to do an entry burn. Otherwise, the heating from those, Mach 2, 3 or whatever will damage the bottom of the rocket. Starship just bulldozes through that and says, I'm going for it. And yeah, you can figure out the kinetic energy of air moving just over Mach 4 is enough to raise its temperature by about 1,000 Kelvin. So that's why you get the heating.
Yeah. And then, Marcus, they gave it the command, okay, try to land. So this is like one of those abort possibilities that they had, was they could say, nope, let it just hit the ocean and we'll call it a day. But no, they gave it the command to actually come back to the launch site.
Yeah, and that we sort of heard that just after the boost back burn, which is when we expected to. And at that point, they're sort of committed to at least that trajectory. I mean, there would be other abort scenarios, and these are some of the things that I'm really interested in because I would love to know what they are more specifically. Like, let's say it comes down just over sight. A couple of the engines don't ignite like they need them to, and they need to abort at that point. What was the scenario there? Would it have had time to get back out into the ocean? I don't think so, because it's already pretty much on that committed flight path, and the grid fins can only do so much to steer it out of the way. So I'd really love to know, what was the scenario there? Could they swing it out of the way and just crash down off-site? But yeah, we don't know exactly. But we didn't need to worry about that in this mission, of course.
Yeah. And Scott, I mean, those last moments, it came in quite sideways and then sort of did this weird little kick in the end to slot itself in and get captured by the arms. So,
right. I think that was intentional. It was part of their plan. So like at every stage during the descent, they wanted an out. And so it's doing health checks all the way down. It has to do this moment to slow down from high Mach to landing speed. And that involves lighting 13 engines and then shutting down and leaving just 3 engines. And, there's a lot of plumbing going on, a lot of fuel going up, power going down, and things go wrong when you do that. When you turn an engine on and off, it is a highly dynamic event with fuel flows and turbine speeds all changing very quickly. That's when things go wrong. So it looked to me like it did that. It turned on, it turned off, it was down to 3 engines, it was moving slowly. And at that point, it was like, if it had failed at that point, it would have fallen, a few hundred meters away from the tower and not destroyed the tower. But at that point, it knew, it was clear. It then makes that translation inwards. And it's really obvious when you look at it from multiple angles. It purposely had this out right up until the last few seconds that it could have aborted and missed the tower. Because they had to make sure every single thing was working, not just on the booster, but on the tower. Right, the tower could have had some failure, and that would have had them call off the landing attempt.
And it was quite amazing. We could actually see as the chopsticks came in, there was like a suppression system on the chopsticks, shock absorbers on it, and it looks like it's resting on the grid fins, but it's not. It's resting on these pins attached to the side of the booster. And I don't know how big these things are. Scale makes no sense at the size of this
Right,
rocket.
right.
But
Yeah.
It is important to understand those aren't just welded onto the side of the tank. That there's actually a continuous structure that goes up inside the top of the booster and attaches to the top of the tank there. So you've got this complete spar that runs over the top so that it's hanging from that. But yeah, they're very small. And I believe I saw, like, it was a fun tweet or whatever this morning saying, yeah, these probably cost $15,000. But if NASA was going to do this, they would be, $20 million into a study on whether they should be made from one material or another, But yeah, they are small. But I think really the important thing is they are small. They're a lot less complicated than landing legs. There's no moving parts. There's no shock absorbers. All that stuff has been moved onto the tower. And that is the whole point of this design. This insane, crazy design always made sense, but we were skeptical as to whether they would actually be able to make it work in practice.
So I want to know, honestly, what were your odds watching this? Marcus first.
Yeah.
What did you, going into it, what did you think was likely going to happen?
I thought it was probably a 50-50 chance that they would give that call back and say, yeah, we'll go for the return. I thought, yeah, that was a pretty decent chance of that because hot staging, all these systems had worked pretty well in the past flight. But I very much doubted that they would get through all the other abort scenarios that would be somewhere down the line there. Any of those, you got to remember the heating that we saw there on the engines that we've just talked about. Like that could have disrupted any one of those landing engines. They need the 13 to do their planned burn. They could presumably lose one or two of them maybe and still complete it in a different way. But there would have been all sorts of scenarios where that landing burn may not have gone to plan. And this only starts at like 1,200 kilometers an hour or something. They're only 1 kilometer or 2 kilometers above the surface when they fire off this landing burn, and it's descending obviously incredibly quickly. So the likelihood to get through that and have zero issue with the landing burn to me seems unlikely. But they did it. They absolutely did it. And yeah, by the time those little pins touched down on those rails, those shock-absorbing rails, I think the way they seemed to have done it was quite magic. So it seemed like they had sort of let it almost hover there as it touched the top of the rails, and then when the engines cut, that was when the shock-absorbing almost took place, and you saw the rails sink. It's really, really ingenious and simple from the booster side point of view, but incredibly complex on the Mechazilla side of things.
Now, Scott, you identified that damage did happen to the booster, so it didn't get through this process scot-free.
Scot-free.
Yeah.
Yes. No, there was a bunch of little bit things here and there that were obviously damaged, but as they lit up the engines right at the end, there was very obviously debris blowing out and flying away. And that was part of the chines, the covers for some pressure bottles on the side, but there were also like aerodynamic features. And the thing is, we were able to see that in the image. We were able to see it afterwards. It's not bad damage, but we know that it must have happened during the engine relight, because if it had happened earlier, very likely they were in high Mach environment. And if you start something peeling like that, typically it doesn't stop peeling. This was a much more localized event. I think there was like some propellant, oxidizer got mixed in there. There was a little boom and it blew that off. And then there was nothing else. Right, that's what I think happened. It's all bent outwards, so that's what I think happened there. I don't think it was a big deal. They certainly didn't look like they damaged the pressure vessels or anything. But yeah, I mean, the other damage that we saw was the bent, belt nozzles on the outer ring, the booster engines. These are the ones which didn't light up during the descent, and I think that may be related to why those are bent and the ones in board of that aren't. Simply because on the outside, they're feeling maybe a bit more heat from the airflow. And also, I think that since they're not involved in the landing, they're not being chilled. There's no propellant being run through those nozzles, so they're going to get hotter and potentially soften more. So I think those are a combination of effects. And, already we've seen comments from Elon about how they are going to have to figure out how to solve this problem. I think my casual comment was, hey, at least you have a way to run coolant through those exposed nozzles. So, but we don't know how they'll deal with this going forwards. But that is actually a showstopper. You can easily replace the paneling on that, but you want to replace all those outer engines because the nozzles got bent out of shape. That's a serious threat to your
That's
rapid
expensive.
reusability. Yeah,
Yeah,
expensive in time. Yeah.
Yeah, the biggest comment I've seen around that is things like, is it really the future that they will do literally no entry burn at all, or will they sort of do a smaller one just to reduce a little velocity or something like that to help with that issue? But every bit of propellant you spend that you don't need to, there's less mass to orbit. So yeah, it's
yeah. I think you're exactly right. I mean, I think we talked about this last time that the fact that it was even able to, with Starship, it was able to survive getting through the atmosphere, and we'll talk about this in a second, that, okay, more heat shielding is going to be necessary. They're going to have to give it less launch capability in exchange for better protection. And it may very well be that they're going to have to store more propellant on board to be able to do a better boost back that is more protective to the spaceship itself. And that means they're going to have to be able to have less payload that they can send to orbit. And so now they're going to shave off. And so now instead of it doing 100 tons to low Earth orbit, it can do 98 tons to low Earth orbit. But we're still so far in the realm of science fiction at this point of capability that it's all it'll end up being however good it can possibly be, and they'll engineer it as best they can over multiple iterations. We're still well in the clear at this point for its capability as a launch system.
Well, right. I mean,
let's continue on the rest of the story then. I mean, we were all.
I'm going to say we're not in the clear.
Picking our jaws up from the floor.
We're having to build a bigger one. So I'm going to say we're not really in the clear because this Starship super heavy design is too small, doesn't have enough margin. So to make it useful, that's why they're doing V2 and V3. So that's
yes.
But I'm going to say another way.
But there will end up, in the end, there will be. Yeah, I mean, in the end, there will be a balance between the amount of propellant that you can use to carry large payloads into orbit, matched with the amount of propellant you're going to have to keep on board to stop your booster from tearing itself apart as it comes to the atmosphere, balanced by the thickness of the heat shield, the amount of mass that's required on the heat shield for Starship for it to not completely tear itself apart. And there will end up being this final balance. And that will tell you what the true launch capability of the system is, but it won't be nothing. It will probably be lots.
Yeah. I mean, at the moment, there's a real mass penalty for a lot of the over-engineering they're doing in some areas, and there's some areas that obviously need more engineering and more mass to protect them, such as the forward fins. We'll go into that in a minute. But, in the end, the big question is, can it be reinforced and can it be light enough to do all the things that they wanted to do? And as Scott said, you've got a version 2, version 3 that are coming that are much taller again. And Raptor version 3s, which are more efficient and less weighty themselves, which we hope will improve things as well. So with all these little changes, we hope to see a much larger mass to orbit capability. But at the moment, we're really not sure what that capability is. The Starship is fairly minimal propellant as far as we can see once it gets to its near orbit.
All right, well, let's continue the story then. So I think, like I said, as we all picked our jaws up off the floor and looked back at our screens, watched Starship continue on to make its journey into space. Marcus, did anything interesting happen for the sort of first part of that flight?
For the Starship side, we were sort of all largely just watching the booster, and then the Starship was just in orbit. As far as we kind of knew, it's like, oh, okay, yeah, there's a Starship still going. We better look back at that. That was a little more routine. Once we saw it up there coasting along, it just looked beautifully smooth, beautifully in control, absolutely amazing views. And this was, as Scott said at the start of this, the weather couldn't have been better for this mission. It was definitely the best views that we've seen on any of these Starship flights. So I'm interested to see if we'll have camera views of the second stage from the ground, even being released that go much further than we've seen so far. And likewise being able to see some of the footage that is so far missed because the focus very much has been on the booster. But yeah, it came right round. Smooth as anything, and started its re-entry process.
And then once again, we saw those hot gases build up on the outside as it was starting to interact with the atmosphere. Scott, that all looked fine to you?
Yeah, I mean, it all looked so. Again, we have multiple steps during the re-entry, right? You have the really thin upper atmosphere where you're going at orbital velocity, and you just get this very sort of benign heating. It's really hot, but it's really, it's hot enough to melt things, but it's not like, it's not thick. It's not an aerodynamic issue. And then as you get lower, you fall into the atmosphere, then you're starting to get aerodynamic lift. You've got pressure and heat at the same time. And that's the majority of this. And of course, during that, it's steering itself because not only are they wanting to land, they want to land with precision, right? And yes, and of course, during this whole procedure, during this whole entry, we're able to see this because of the amazing connectivity of Starlink, which I don't have.
Right.
You're going to have to explain this to everyone out there that my connectivity is failing continuously right now. It's Comcast.
Yeah, it'll upload after the fact, and no one will ever know. But
anyway, so, yeah, you get through this, and then you go to the final section, which is almost all aerodynamic forces. That was my point.
Right. Yeah, and I think so. I watched your video, Scott, and I think something that you maybe missed them say was they had actually covered the flaps in aluminum or aluminium, as you might say, as you both might say, and that was used as a kind of a canary in the coal mine, that the aluminum will start to melt when the steel is starting to lose its structural integrity. And that then tells you that, okay, we are starting to move into the damage zone. And compared to what we saw with the previous flight, it was definitely holding up much, much better. So, Marcus, do we know what they had done to upgrade the heat shield for Starship for this flight compared to the previous one?
Yeah. So what they said after the fourth flight was that they were going to put in another new underlay. And then for a few months, we actually watched them strip all the tiles off, every single one, because the next ship in flight, Ship 30 that we were watching in this mission, it already had a fully installed heat shield, but they ripped it all off, completely started from scratch pretty much, and they put quite a thick ablative layer underneath, a black layer. Sort of looks like a big thick rubber mat, but I'm assuming it's more complicated than that. And then the new upgraded tiles, again, a fully new set that was supposed to be, I think they set up to 200% the reheating capability, something like that. I'm not 100% sure on that now. But those tiles then went on top that gave them essentially a backup heat shield. So with this, I assume that they were certainly applying those areas to the forward flaps where we saw the main issues last time. And it seemed to work, like it right through. And I think that they got the vehicle right down under, I don't know, like maybe 14,000 kilometers an hour or something before you really started to see burn through happening. So that was a pretty big improvement. But yeah, as you say, still had some issues.
Yeah, it was definitely, again, not getting out scot-free. Scott, what damage were you seeing as it was sort of hitting the thickest, hottest part of the atmosphere at that point?
Right. So, I mean, early on, you could actually see that there was discoloration happening in some of the structural metals. And I was originally not sure whether that was just lighting, but a lot of people agreed that it was actually discoloration that we're looking at. But yeah, we had burn. The first clue we saw was the backside of a hinge starting to glow. And it was initially it was sort of in the middle, but then these are both forward hinges, and the forward hinges are the hardest ones because it's on a curved surface. So you've anchored it in multiple points. There's different pressures going around, and when you have different pressures, you have sort of preferred flows, and it would be finding a spot and then enhancing that, and probably blowing hot gases inside the wing structure. And from that was leaking through. Now, yeah, one started slightly further out and another was slightly closer in, but both of them were just starting to break down. And, this happened, later in the flight, as you start to get into the thicker parts of the atmosphere and there's more pressure to actually, you've got less heat, but more pressure to drive the gases into cracks and through that part of the hinge where it can intrude and start damaging things. But the main thing was, while we saw like holes and stuff developing in the structure, the fins did continue to move. And that's important because, of course, they needed those to continue to control their descent.
It was too bad that they hadn't sort of timed things so that it could be returning during daylight off the coast of Australia.
That was intentional. They've always landed in the dark so they can see this stuff.
So they could see the burn through. Yeah. So it's like you have to choose. Like, do you want to be able to see the flaps moving and sort of see that everything's operational, or do you want to be able to actually see the hot gases burning through your landing fins? But I wonder sort of if they could go afterwards, take the video, what would be more useful to them to be able to study it frame by frame? Because for a lot of it was very dark. You couldn't really see what was going on.
Well, and they had lights on board as well. They actually had lights that were shining on some of these surfaces, so as part of the analysis. I think if you look at the launch window, they had a half-hour launch window at dawn. They intentionally chose this for their launch site and their landing site to make sure the lighting conditions were what they wanted. They wanted daylight at this site and they wanted nighttime when they were landing. That's the decision they've taken. And, I'm sure they had big discussions to decide what was the best for both of those. And they've decided that landing at night gives them better... it's easier to see when things are getting hot, when it's dark.
Yeah. And it could very well be they had like infrared cameras that were showing the heat changes with more precision. So who knows what they had. All right. So then it sort of didn't get destroyed, and then it clearly cooled down pretty quickly once the air was cooling it down and it wasn't hitting that sort of high velocity. Flipped into the belly flop maneuver. Yeah. And Marcus, how did that all play out?
Yeah, I mean, that was all really beautifully smooth as far as we could see. A lot of it was in the night shot where we really wasn't seeing any views much at all. But as soon as it sort of passed down around that, 6,000 kilometer per hour mark, that really showed some pretty dramatic cooling at that point, and all of a sudden everything sort of went pretty black. But right before that, you could sort of see they had great control of that forward flap that was damaged. I'm assuming the other one is probably damaged in the same way. We didn't actually get to see a shot of that. We had great shots on the other, the aft flaps. They were really great. They looked perfectly fine all the way through. And interestingly, there was, like you were talking about there, with how many sensors have they got all over the vehicle. They would have data that we would not be seeing, and absolutely loads of it. But there was also some test tiles, different types of them too, up on the payload bay. There was sort of 6 of those up there that were probably trying to record all sorts of interesting stuff there in regards to which sort of heat shield would perform better or worse. And there was also a couple of missing ones from the aft section, like there was on Flight 4. So there would be data around all that stuff. I'm sure they probably had little sensors there on those. More to the point, though, as it came down, beautiful control, and just as soon as it was time to do that belly flop maneuver, and it sort of happens just as it hits zero. I think their altitude just needs a slight little bump there.
It's 1 kilometer precision. Zero. That's the problem. Yeah.
yeah. We need a decimal point in there. It flips down, and beautiful, absolutely textbook. You could sort of see there was still some horizontal velocity and the gimbal on the engines. You could sort of see that fighting to zero that out, and beautiful splashdown. Just incredible.
Yeah, you could see the water, and then when I guess the plume was hitting the water, it was like illuminating the water from underneath, and it turned this very beautiful light blue color, and
for a moment,
and then like the camera switched.
Well,
and I was not expecting
you could see
that.
It fall over first.
Yeah.
And then
so it was falling
switches.
over. Yeah, and then the camera switched. Did you guys know that the camera was going to switch?
No.
I knew that they were aiming for a specific target. I didn't know they had hit the target until I saw the camera switch. And then I was like, they hit their target. And so that is the amazing part, because they had to fly this thing, and they fly it with these flaps. The control system has to adapt to the damage to keep it stable. But not only that, it has to then adapt to keep it on target. So you've got multiple layers of control that are being applied, and they were able to compensate for all the damage, all the deficiencies, whatever imperfections it had picked up through the atmosphere, and put this thing down on target. They clearly didn't do that with the previous one because we never got the other shot. But that's it's really good because guess what? They have to start figuring out how to recover Starship by catching it.
Yeah,
they need that precision.
And so we got that view from this buoy in the ocean, seeing this thing nose down, like the Titanic, kind of starting to sink into the water, on fire. One final explosion
cloud you actually see.
Yeah,
like the thing just disintegrates, and you literally see this plume that looks like a mushroom cloud. And I looked for it on satellite imagery, and I couldn't find anything that picked that up. But I'm hoping that something out there caught it, because it was probably quite a big event.
Yeah. And do you think that they'll be able to capture any part of the debris, or is it just like it was sinking fast?
Well, it depends on what's still floating, right? These pressure vessels, sometimes they can hang around. Who knows? But yeah, it's deep water there.
Yeah. But I mean, they were right. They were right there. I mean, they had an automated buoy that close. They could have just zipped. Maybe there were boats nearby too, and they could.
Well, I initially thought
for a capture.
They say it was a buoy or a buoy, as you Americans say, but it looked like it was almost moving. And if you think about it, it has to have some sort of position keeping because it's in the middle of the ocean, and they want it to remain still. And the barges, the landing barges, they have thrusters that keep them in position. So I'm guessing this had to have the same kind of thing, surely, no? But anyway, I don't know if it could zip over and get a closer look. Regardless, I'm sure they were nearby, but not that nearby.
Like, I wonder if next time they could just have a landing barge there and then just have it land, not be capable of supporting itself, fall over, explode, but still
have a big net in the water.
Yeah. That's a good idea. Have a big net between them, and they could just capture it, made of titanium.
Yeah, that's a good idea. I like that.
Yeah,
I mean,
they could probably.
If they can do that, enough precision, maybe they could actually take one of their landing barges out to the Indian Ocean.
Yeah, that's what I'm wondering. All right,
but they need to have landing legs.
Did we learn anything after the fact, Marcus? From SpaceX, from Musk, from anyone?
Yeah, I mean, a lot of the talk has been around the booster side of things. Obviously, they had some beautiful released footage just earlier today, as we're recording this, that actually showed the camera from the little pin on the booster coming back, the catch pin. So you've got that camera view now that you can follow all the way from the landing burn right down to actually touch on the chopsticks themselves. So that's a really great new view to see, because you can see how intricate that process was, where the landing rail sort of sinks underneath. So that's been really good. And obviously, since the launch, we've had a lot of information about the condition of the booster engine bells and things like that, which we've sort of already covered. But one of the things that's cool is that, and what I didn't expect, was that they just placed it back on the orbital launch mount. And the reason why we didn't expect it is because they took the alignment pins off. These alignment pins sort of sit on top of the orbital launch mount, and they lock into place on the booster as it's coming down to guide it very carefully onto the catcher, onto the launch mount and the actual sort of various platforms right around that support it all. So I didn't think that they would be able to bring it down without those pins, but they did. So they must have just carefully guided it in and had manual checks to make sure that it was all okay. So they placed it back down there. We had some tweets and stuff from Musk saying that, yes, reasonably superficial damage, but amazing result and these sorts of things. So, yeah, look, it's just been such an amazing thing. And I don't even know really what to say other than it's just incredible that we've got to witness this sort of history of this being done for the first ever time, and being able to see a future where this is like a commonplace thing, kind of almost like what we saw with Falcon 9 landing on the barge the first time, and to it now being commonplace. I think we're going to see these huge towers just catching vehicles out of the air. It's like it's a crazy thing to think about.
Yeah, I mean, one thing to consider, I think, is that since this requires a tower, this is inherently a return to launch site for the booster. Now, they've saved some mass on the booster by eliminating the landing legs, but a return to launch site needs extra propellant to fly back, and so you're getting less performance from your second stage. Falcon 9 can, of course, land on the barges, which means it actually has more propellant in reserve or in the second stage. Of course, the other thing we saw today is you could totally expand the Falcon 9s or the Falcon Heavy booster cores if you say want to throw a payload at really high speeds. So, what I'm wondering is there still hope for, or is there still a place for Starship if it doesn't embrace rapid reusability? Is the mass margin useful for certain types of payloads? But anyway, at what point does Starship become better than Falcon 9 is a question that I'm still pondering.
Yeah. There's an interesting sort of scenario that they talked about years back, and it hasn't really been approached again a great deal lately. But they were planning on having these huge towers out in the ocean for launching and stuff. These are essentially some big adapted oil rig. Exactly. So whether those sorts of ideas will come back into play to give it more margin, if it doesn't have to do boost back, it's got more propellant for a little extra velocity and probably an entry burn at that point, because if Falcon 9 didn't do an entry burn for those drone ship landings, it'd be toast. So yeah, it's sort of an interesting scenario.
So go back to Phobos and Deimos, have those oil platforms, but have them be Mechazillas that are anchored on the ground. They catch starships and then they shuttle them back to Boca Chica for launch. And so maybe it doesn't happen within 4 hours. It happens within a week or 2 weeks or 6 months or whatever it takes. And then that gives you a lot of that fuel back. That might be a really smart way to go.
And for the Starship, of course, you've got this, it's not quite the same problem because Starship is going to be in orbit, and it can sort of choose to, as long as it's in somewhere in the vicinity of the trajectory or the orbit that it's on, it can choose to really land anywhere. So it doesn't really have the same return to launch site issue that the booster does. There's pros and cons for either
side. To go at least once around,
Mm-hmm. Yeah,
exactly.
Now, Scott, are we expecting to have another big long wait for the next test, or they're going to look at their license more quickly this time?
Right. So the official word is that since every test goal was within the criteria set out by SpaceX, this is great. There's no investigation required. So in theory, SpaceX are already, I believe they're allowed to do the same type of launch plan again with no changes. They can very quickly get a launch license should they decide to do that. And it's really up to SpaceX as to how much work they want to do, how many changes they kind of want to try to get into the system before another flight. But what could they do in another flight? Well, first of all, catching the booster, it was impressive that they did it once, but they are going to have to actually do this every single time if they want to demonstrate rapid reusability. So just doing 2 of those in a row would really help their argument. But also, they could start doing experiments with Starship. Now they've demonstrated precision touchdown. I'm not sure they're wanting to do that with these designs of Starships, but they could go into a complete orbit. Or they could actually try to target a drone ship or something. I don't think that we're going to see Starship coming back to Boca Chica anytime soon, because that is a whole complicated thing. But they should, on the next flight, they could actually land Starship in the same location and target a drone ship or have something close by.
Mm-hmm.
And
or
I think
even land in 50 meters of water.
No, they would that, but then they would change their landing site, and I'm not sure how that affects the licensing. Mm-hmm. So, if they change the landing site to somewhere else, they might have to then go through a relicensing process.
Right, but that might be worth it. But yeah, when you think about the tasks that need to be done for it to be ready for being the human landing system for the upcoming Artemis missions, I mean, the big outstanding thing is orbital refueling. So
for that, they're going to need 2 of them.
Yeah. And they need mass to orbit. It just comes down to having mass to orbit. So we need to see how much payload they can actually get up there. Because if
Yeah.
you know every kilogram of propellant that they want to refill with is you know more performance that they need, and at the moment. And sort of it's unclear. I do see a lot of speculation to sort of suggest that, maybe they're actually dumping fuel or dumping propellant or not even fully loading the vehicle just to allow their tests to do what it needs to do, but not really anymore. And, you know, that could be a fair argument, but I don't see any evidence for it. So who knows what the real payload capability is as it currently stands. Yeah, it's going to be interesting to see. But I don't think that we're going to see an exact repeat, even though, like, you're right. They certainly did say in the assessment here that just came out the other day that Flight 5 and Flight 6 can run the same profile. But SpaceX don't usually do the same thing twice. They'll push some new boundary, which
Right.
I would be surprised if they don't require another license just because of some new boundary they want to push. I would love to see them go fully orbital, and I would with the Starship at this point, because I think they've demonstrated good control during those coast phase for the last two missions, and even the last 3 missions. But what would be nice would be if it could come right around.
But yeah. Is there anything?
You're right. Actually, 3 a.m.
Right. But is there something that they can do to expand their testing without requiring a new launch
without
license?
going fully orbital?
Right.
Yeah, that's a good question.
But or they might have to just go for it and get the new launch license if they need to move their program along. It might just be the sacrifice that they're gonna have to make. But you know, if they're gonna have to launch 15 of these things to refuel the human landing system, are they going to be able to reuse those boosters? They're going to have to wear away the Raptor engines on 15 separate different boosters. I don't think so. So I think they're going to have to sort out a more rapid reusability, less damage to the booster. And so there's definitely a lot of engineering tweaks that need to happen both in the heat shielding of Starship as well as the reusability of Super Heavy.
Right. I think they can definitely take a good hard look at the booster reusability. For example, figuring out how to keep those outer engines from getting warped, right? That is something that they're going to have to figure out. And maybe they do a single launch with the same license just to figure out a better way of doing that so that they can then turn it around and fly it again fast.
The important thing as well is that right now they've actually got a returned booster that they can analyze, because that's something that they haven't been able to do before. They did fish the old booster out of the ocean, or parts of it, parts of the aft section here, a few weeks back from the previous flight. So that was good to see. But, you know, after the impacts and things, who knows what damage was caused by the flight and what was caused by the impact to the ocean and everything that happened after that. So it's great that they now have that data, and they'll be able to see exactly what needs to be reinforced or rethought through.
Yeah, I'm pretty sure those engines didn't fail from ocean silt, you know.
Yeah,
right.
Exactly.
Yeah. Now, so I've been feeling this really weird ambivalence for the last couple of years now, that we're in this weird murky limbo where on the one hand you've got the kind of traditional perspective with NASA using the Space Launch System at $4 billion a pop for tens of billions of dollars for its development costs. It's unsustainable over the long term, and yet that is the plan to send humans to the moon. And then on the other side, you've got this stainless steel skyscraper being built rapidly in Boca Chica with tests happening at a fraction of the price of what it would cost to launch Starship. At a fraction of cost of what it would cost to launch SLS. And yet it's not ready yet. And I think before this test, you could make the case and say that it's possible that they will not solve these problems, that it looks like they're on the right track, but it might just never work out. And so it makes sense to keep going with Space Launch System. It makes sense to keep going with all these traditional, you know, let's go ahead with the Ariane 6. That's the way. The Vulcan rocket, you know, no one is really charging at reusability in the way that SpaceX is. And I think their plan is just to hope SpaceX won't be able to figure this out. Do you feel like
the other providers as well are interesting?
Did that reality come apart?
From Europe today. Yeah. So Rocket Factory Augsburg today put out a letter basically congratulating SpaceX and saying, "What the heck, Europe? We're now 2 generations behind in terms of rocket reusability, and nobody is thinking about it."
Yeah.
So that sentiment is being spread for sure.
Yeah. Yeah. And so it felt to me like when that booster got caught, that was the moment that anyone who was hoping that SpaceX wasn't going to figure this out is wrong. And that they have figured this out, that now it is a series of engineering challenges that are going to need to be optimized. And there's a laundry list of things that need to be figured out, but they're past the part that might not have worked out and would have just doomed the entire project.
Unknown.
The biggest unknown. They could spend 10 years, kind of like what happened with Falcon Heavy. Like it took 10 years for them to make what should have been a relatively easy fix to the Falcon system to finally make this thing come together. And I don't think they're even still super happy with how the whole system runs, but it's the only heavy launch rocket that's out there right now. So that's the one you got to take. But now, yeah, if you don't have a fully reusable 2-stage rocket platform plan, you're just going to give all of the business in the world to SpaceX.
Yeah, I mean, there's really no doubt about that. I mean, SpaceX have already taken such a huge, colossal chunk of the market. When you really look at mass to orbit, and admittedly, a lot of that is Starlink, which is their own product. But they're putting such a huge amount of mass to orbit. It's already kind of eaten it up, and to a degree, there's use cases for some of the other vehicles. But you worry about things like Vulcan, which looks like a very beautiful system. Still uses. It's attempting to do some reusability with some of the smart systems, I think, in the future, maybe. But, they're also looking at being bought out. So these things are interesting questions. And obviously, we're really looking forward to New Glenn's first flight because that is supposed to be partially reusable. And if it is, it'll be just the second one that's successfully partially reusable, or at least demonstrated. And Rocket Lab have done it as well with a much, much smaller vehicle. So I shouldn't write them off either. But, they're approaching Neutron rather than really expanding on their ideas of reuse with Electron, as far as I can see. So these are things that seem to be obvious, but not necessarily implemented by other countries.
And China, of course, have multiple launches.
Exactly.
China's doing it big. They got a lot of different versions. But yeah.
I would say I know there's several companies in China that have demonstrated different versions of reusability to various extents. I mean, in some cases they're catching up to. It's funny, you sort of see two paths. Like on the one hand, they're trying to catch up to the Falcon 9 system, and then on the other hand, you're watching them catch up to some of the initial tests of what they did with Starship, like was it Dragonfly, the original hopper that they made? Like you're seeing hoppers that are the grasshopper. That's right, the grasshopper with but using methane engines and launching vertically and landing, so you can see sort of multiple paths going at the same time. So I think while Europe is asleep, while other rocket companies in the US are waiting, while Russia has gone to war, China is taking it fairly seriously, and I think we're going to see.
And China has the unfortunate advantage of not being too worried about regulations. So, where the US do really scrutinize, as they should, a lot of things, they are admittedly too slow in actually getting, making sure that this remains very competitive when you've got the Chinese on the other side that really don't mind dropping rocket bodies just in the general vicinity of the population and things like this. So, to a degree, it may not turn into a fair fight when it comes to that competition. So, you want to make sure that these projects like Starship and anything else, New Glenn, you don't want them to be held back by anything too silly or non-safety related.
And China also has a history of picking winners, as in acquiring the winners and nationalizing them.
Yes. Mm-hmm. Yeah. No, I mean, there's all kinds of reasons why China is able to catch up technologically speaking. So I think we're at the end. But this really, like, I'm at a loss for words. I really am. And I think for a lot of people there that are watching this, I hope you all feel the same way, which is like you can't believe what you saw actually happening. Yet there were people there who saw with their own eyes, and it happened. And we are now in
I saw
the
grown men crying at this, and I fully support it. Right?
Yeah. And because you're thinking about the implications, you're thinking about what this unlocks, and not just a zillion Starlinks. Like eventually this could be bigger space telescopes. This could be sending human missions to the moon, to asteroids, maybe eventually to Mars. Everything changed. I'm so glad.
Yeah, no, it's just incredibly inspiring. I mean, it's the best tweets that I could come up with. Are you kidding me? I think that was one of my tweets. Or no freaking way. These are the best things that I could come up with at the time. So, and I still feel that way. It's one of those things that's just so inspiring. You kind of feel like you're dreaming, or it's just an emotional thing. I think for anybody that's been following this for the years since we've been saying they'll never do that. They'll never catch this thing. What a strange, silly idea. And sure enough, it becomes the science fiction becomes the new norm somehow.
Science fact. Yes, I know.
Science fact. Yeah. Fantastic.
Yeah, we already have our personal communicators and tricorders. I want to get the spaceships.
Yeah.
Well,
exactly.
Scott, what are you working on that people should come and check out on your channel?
Well, I've been flying a bunch of simulators. I was visiting Boom Aero the other day, and I went and landed their Mach 2 whatever XB1 simulator on my first try. Obviously made videos about the Titan submersible and the dangers of multi-layer composites, very thick stuff. Visited Longshot as well, who are building a giant potato cannon, which may one day shoot things into space.
Oh, that's fantastic. Marcus?
Yeah, no, we're working on a couple of things around lunar missions and videos of that nature, and hoping to have some things in the pipeline in January, which I can't actually talk about yet. But yeah, it's going to be a bizarre couple of months, I think, and fingers crossed. We're just hoping to see some great progress here with the next flight. Maybe we'll see this sooner rather than later. Who knows?
Well, so I just want to give you guys some feedback from the fans, which is that they eagerly look forward to this conversation. We really appreciate you guys being so generous with your time, and I think they really enjoy the chemistry of the three of us chatting. I think there may be one more. I feel like this is the penultimate episode. The ultimate episode will be when
I think
Starship.
That'll be explosion dependent.
I guess that's true. Yeah.
Exactly.
If there's kabooms, then we'll have to keep going. But at some point, the whole system will work, and I think our work here will be done. But until then,
as soon as we're out of those flight tests,
as soon as we stop feeling like we're going to cry when watching this, that's what I'm hearing.
Yeah. But thank you again. I really appreciate it, and I know the fans really appreciate it as well. It's such fun, and I look forward to chatting with you guys again. All right, take care.
Yeah, no worries. See you
Fly
soon.
safe.
I hope you enjoyed that conversation with Scott Manley and Marcus House. Now, I'm going to give you some sort of final thoughts, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Giltonan, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, SpiderSwap.io, Stephen Krasaki, Stephen Fowler Munley, and Vlad Shipley, who support us at the Master of the Universe level, and all of our other supporters on Patreon. It seems really surreal to see that rocket successfully land on the tower and be captured and not be a big explosion and a crater in Boca Chica. And, I was not expecting them to go for it. I think if you had asked me in advance, I would have given sort of a 25% chance that they were going to go for an actual capture and that they would have been able to pull it off. And they did. And I'm so glad that they did. And that, I think, that matched with the successful return through the atmosphere and sort of seeing the minimal damage to the heat shielding gave me a lot of hope. And so I think at this point, although there is still an enormous number of things that SpaceX has to work out, they all seem to be sort of solvable, engineerable problems at this point. and now we're sort of moving to this next stage of heavy lift rocketry. And, who knows how long this is going to take. I mean, we're probably, after all this excitement, we're probably still going to have to be patient as the next parts and pieces get put together. And of course, time is of the essence here. SpaceX has to be able to get the human landing system ready, demonstrate that they can do refueling in space, get this thing to the moon so it can take the astronauts down to the surface of the moon in 2026. So there's no time to rest, no time to wait. And yet, I think, if you're feeling excited, enthusiastic, grateful, amazed, I'm right there with you. It was an incredible day for spaceflight, and I can't wait to see what happens next. All right, we'll see you next time.